Hi everyone, I made a SodirChat. So SodirChat is a chat application for the Norwegian wells database that is maintained by Sodir, or the Norwegian Offshore Directorate database. So the purpose here to compress 50 years of oil and gas exploration in Norway in a chat that is powered by Google BigQuery AI. So I want to just share 5 outlines here. So I want to start from the problem, and then what the solution looks like, and then how the SodirChat architecture looks like, and then web scraper, and then I will go with the demo. So this is the motivation why I make SodirChat. So Sodir itself, it is a website or a database that contains lots of information about wells explored in the Norwegian Sea and the North Sea. So if you go there, Sodir is a website, and then there are a very big database of wells there. So currently it has 9,000 wells there. So you can imagine how hard is it to select one well and then get information from the database. Basically, Sodir contains of a text as you see there, and also you also have the map and also the core photos. So this is not just textual. You can see here, this is a multimodal. And the problem of this database is that it is a very underutilized data. So there are lots of information, rich of information, and people can use it for helping in their workflows, for example. And this data is not really used currently by the geologists and engineers because it is caught in this form of website. So what I develop here, I develop a solution called SodirChat. It's a chat app for user, so that the user can directly retrieve information about which wells they are interested in. And this SodirChat, it exposes to the website through the BigQuery. So by using this solution, engineers can make decision in minutes, not days, because they can just interact with the chat, and also making some values from the legacy data, because most of these wells are explored in the past and they have lots of data. And then also it will be a disruptive technology for the oil and gas exploration and production. So this is the architecture that I built. So the main stack is the beautiful soup for scraper to scrape the data from the website, which contains text, images, and then these two form of data, the text and the images, are uploaded to the Google Cloud storage bucket, and then each of these are converted to a BigQuery database, where later on from this database, if you see here, it will be made into the embeddings, so converted to the embeddings, where this one is using the text embedding 003. So when the user wants to interact in the chat, the Gemini 2.5 Flash, it will be the model to generate the answer, and then run the vector search inside the BigQuery, and then the result will come into the Streamlit. So this is the general architecture. So I want to just introduce you to how I made the web scraping. So this is just a simple web scraping, but very powerful because it can scrape 50 wells. So you see here, this is the raw text data, and then also we have this core photo and the map data. So and then from this one, it will be converted into the embeddings. So I think I will show something here in this tool that I've already made. So this is the scraper. So you can see this is the scraper. So I need to run this one to scrape for 50 wells. You can also increase it to 100 wells. And then from this one will be uploaded to the bucket. So this is the code to upload to the Google Cloud storage bucket here. So it will be here. So if you can also change your storage bucket as well. All right. And then after this one, I also included a README here, so that you can also see how you can run this one. You can do the BQ load or BQ make here to upload or to convert from the Google search bucket to the BigQuery. And then after that, you need to run this refresh factor. So what is it in here is to embed all the text and the images, which we already uploaded to the Google Cloud Storage bucket, and then we convert it to the as a BigQuery database, and then this will create the embeddings. So this is, if we go back to the slide here, so we have here, this is the schema. So you can see this is the this is how I arrange all the data into different BigQuery schema here, and this is the this is the vector search later when the user. So after this, I will take some minutes to show a demo of how we can run this SodirChat in our local machine. Inside this Python file, this is the app, the Streamlit app. So if we go to the this function, so this is the function that is used to do the vector search from the BigQuery. So here it does this vector search SQL dual, which is basically from this function. So this is my implementation of BigQuery vector search here using the cosine similarity search. Yeah, if we go back to app.py, so this is the implementation, and yes, it is implemented here. And then, so if I want to run the app, so I can just use Streamlit run. And then here we can have this very easy app to use. So let's wait for a couple of seconds. So this is the SodirChat. So in this app, user can give any query related to the Sodir data, to the Norwegian database of wells. So we have currently 50 wells here. And yeah, this is just the interface for you to use. For example, I want to increase to 16 files to search, for example. And then I want to increase my max token, maybe this one. So yeah, we can ask something, for example, which reservoir is, well, let's pick one well called 15913 is drilled, and describe the reservoir. So we can just ask it, and it will run on behind the BigQuery vector search on the two databases, the text database and also the image database. So let's wait for a couple of seconds. So here you can see there are two results here. So this is a multimodal implementation. We have here, this is the image and this is the document. So it also has the core photo here and also the documents. So this is basically, if we go here, we can see the information about this well, but it does the search to find the relevant chunks of the document. So if we see in the answer here, so well, 15913 was drilled into two main hydrocarbon reservoirs. So it recognizes this formation. This is what geologists want to use this information. So it also gives detailed information of each formation here for Heimdall and for Hugin formation. So it also has this citation here. So number one and this one, and you can go to this references to see the actual page, right? This is just basically what we have in the Sodir website, okay? And then if we go back to the app, you can also see this core photo here, but you can also give something like give me core photo of well 15, 9, 13, for example. So it will just give the core photos. So you will see here, there's the core photos. So you can click in one of the link there, in the second link, for example. So you can see all the implementation here, okay? And then, for example, I want to show me the map of well 15, 9, 13. So it can show you all this one. So you can see this is the map. It will directly go to the map here, and it will show the map. So we just need to wait for a few seconds to load the map, because this is a quite big map of the Norwegian Sea. And it loads the layers, so we can see here, this is the map of this well, right? So yeah, so this is basically just to load the map. Okay, so this is the demo for the SodirChat. It is very useful to query any data related to the exploration wells, which we already have like 9,000 wells. So yeah, this is a useful implementation of BigQuery for retrieving a large database in the website.